Right. Hi, everybody. Dr. Marty back. Today we're going to continue talking about functions. We learned about function machines and how to use them, function notation. We're talking about graphing functions today. We're going to start with what I'm going to call graphing parent functions. So for your notes, you should have gotten a bunch of tables that look like this. Okay. We're going to start with graphing what we're calling parent functions. So I've gone ahead and already cut these out and glued them onto a piece of graph paper. That's like what you would have in your notebook. Okay. If you haven't done that, go ahead and pause the video and cut those out, and then get ready to glue them in. You can just pause it as we go and add as we're going. Okay. So here we're going to graph parent functions. Parent functions are the base functions that you might see, and they can be modified in various ways. So I'll show you some examples of how they can be modified. But these are the basic base functions, okay? So the first one, this is actually the linear function. This is y equals x, okay? So this is a table, and on the left we have the x values. So this gives us our values, -2, -1, 0, 1, 2. What we're going to do is we're going to plug these numbers in to our function y equals x. In this case, the y is the same as f of. This is the same as f of x equals x, okay? And we're going to solve for y, and then we're going to get an x and a y coordinate. We're going to end up with 5x and y coordinates, which we can then graph. All right, so I'm going to zoom in just a little bit and clear this up. Okay, this is an easy one. F of x equals x. So y equals x. So -2, y equals, plug this -2 in, -2. Our y value is -2. Our point is -2, comma -2. Here, y equals -1. -1's our y. We get -1, comma -1, right? Our x value is over here. Y value is over here. Y equals 0, right? 0, comma 0. You can see where this is going. Y equals 1, 1, comma 1, and y equals 2, 2, comma 2. Okay? So now we have a set of data points, and we can graph them. So I'm going to make my graph, my x and y axis. But I'm actually going to use a different color. I'm going to use red to graph them. Okay? So our first point, -2, -2. We're going to go -2, right? This is the x. This is the y-axis. So x first, so -2, -1, -2, and then down to y, -2. You've done this before. -1, -1. You go -1 to the left, -1 down, 0, 0. +1, +1, 1 to the right, 1 up, +2, +2. 2 to the right, 2 up. Then we can just draw our line. Now, ideally, you use a ruler, but I think I can draw it well enough. And that is our parent function, y equals x. Now, this is called a linear function. Linear means a line, and you can see that this is linear, meaning it goes in a straight line. Okay? So the parent linear function is just y equals x. Every y value is the same as the x value. Okay? Next, we're going to move up, and we're going to look at this next one, which is y equals x squared. Let me just adjust this so we can make sure you can see it. Y equals x squared. All right? So we're going to do the same thing, but this time it's going to look just a little bit different, because when we plug in, so here we're going to get y equals -2 is x, so -2 squared. Sorry, I forgot the negative. -2 squared. Well, -2 squared is +4. I'm sorry about that. -2 times -2 gives us +4, so our y value is 4. So if our x value is -2, our y value is +4. Same thing here. Y equals -1 squared, which is +1. Write in the positive end to make sure you know it's not negative. Put a 1 in here. -1, comma +1. Y equals 0 squared, which equals 0. 0, comma 0. Y equals 1 squared, which equals 1. 1, comma 1. And y equals 2 squared, which equals 4. 2, comma 4. Okay? So we can go ahead and we can graph this. I'm going to draw my line, my x-axis. Draw my y-axis. All right. Now, I'm going to use that red again to make this graph. Oops, make sure you can see it. Make sure you can see what I'm doing. Okay, so negative 2 comma 4. So I go over to the left 2, right? This is our x. This is our y. Oops, you can't see that. Sorry about that. There's our x and our y. So we go negative 2, 1, 2, positive 4. 1, 2, 3, 4. Negative 1, comma 1. Negative 1, 1. 0, 0. Positive 1, and 2, 1, 2, 3, 4. This is a parabola. It looks like this. Okay. It's a parabola. And this is called the quadratic function. We're going to study quadratics in detail later on. Quadratic equations, how to solve them later on in this year. But this quadratic function. Okay, so we had our line up here. I'm actually going to add line, right? This is a line, straight line. Okay, here is a parabola or a quadratic function. Okay, let's move on to the next two. Here we've got y equals x cubed. X cubed. This is the cubic function. Cubic function. Okay. So we're going to do the same thing. We're going to plug in our value of x in for y. I'm going to make it so you can see this clearly. So we got negative 2. So y equals negative 2 cubed. Now this is negative 2 times negative 2 times negative 2, which is negative 8. Negative times negative times negative gives you negative 8. So negative 2 comma negative 8. For negative 1, we're going to get y equals negative 1 cubed, which is negative 1. So we get negative 1 comma negative 1. For 0, we get y equals 0 cubed, which is 0. 0 comma 0. For 1, y equals 1 cubed, which equals 1. 1 comma 1. And then for 2, y equals 2 cubed, which is 2 times 2 times 2, which is 8. So 2 comma 8. All right, now when we graph this, it's going to look a little bit different. Give me a new one. This is called the cubic function, right? That's our x-axis. That's our y-axis. I'm going to go ahead and graph in red again. So y, x, okay, y and x. Our first value is negative 2, negative 8. 1, 2, it's negative 2, negative 1, negative 2, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. It's way down here. Negative 1, 1, negative 1, negative 1. Sorry, negative 1, negative 1. Negative 1, negative 1. 0, 0. 1, 1. And then 2, 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Way up there. So our graph ends up looking something like this. This is called the cubic function. So when you have something raised to the third power. Okay? Cubic function. Awesome. Move on. Now we have y equals the absolute value of x. Right? Y equals the absolute value of x. Just make sure you can see this. There we go. Okay, remember absolute value tells us the distance a number is from 0 on the number line. It basically makes everything positive. Everything positive. So here we got negative 2. So y equals the absolute value of negative 2, which equals positive 2. We get negative 2 comma 2. Y equals absolute value of negative 1, which equals positive 1. So we've got negative 1, positive 1. Y equals the absolute value of 0, which equals 0. 0 comma 0. Y equals absolute value of 1, which is 1. Positive 1, so 1 comma 1. And then y equals absolute value of 2, whoops, which equals 2. So we get 2 comma 2. Now, let's graph this. Okay, when we go ahead and graph this, we find that we've got negative 2 comma 2, negative 1, 2, 1, 2, negative 1 comma 1, 0, 0, 1, 1, 2, 2. This looks like two straight lines that make a V. Okay? Two straight lines that make a V. This is the absolute value function. Absolute value function. Sorry, can't quite read that. There we go. Looks like a V. Okay, those are our parent functions. Parent functions. So, if I showed you this, you know it's the linear parent function. If I showed you this, you would know it's the quadratic parent function. If I showed you this, you would know it as a cubic parent function. And if I showed you this, I know it's the absolute value function. Okay. 3 more to go, because now I'm going to show you. Now I'm going to show you just graphing other functions. Okay. So this is just graphing functions. Graphing functions. Okay. We're going to do this exactly the same way, but now this is actually the linear function. We said that y equals x, but we've added something. We've added a constant here, and we've added a constant here. So we're multiplying, it's called a coefficient, actually, a coefficient with the x, and then we're adding a constant onto it. So we're multiplying by a coefficient, 3, and we're adding a constant. So let's see what this looks like. Well, if I zoom in a little bit, we've got y equals 3x plus 1. So y equals 3 times negative 2 plus 1, which equals negative 6 plus 1, which equals negative 5, right? 6 plus 1, negative 5, so we get negative 2, negative 5. Y equals 3 times negative 1 plus 1, which equals negative 3 plus 1, which equals negative 2. So negative 1 comma negative 2. Y equals 3 times 0 plus 1, which equals 0 plus 1, or 1, 0 comma 1. Y equals 3 times 1 plus 1, which is 3 plus 1, or 4, 1 comma 4. And y equals 3 times 2 plus 1, which equals 6 plus 1, which equals 7. 2 comma 7. Okay, guess what? I can go ahead and graph this the same way I've been doing all my graphing. Sorry, there's not more space here, but should do the job. So I've got negative 2 comma negative 5 first. Negative 1, 2, 1, 2, 3, 4, 5. Negative 1 comma negative 2. Negative 1, 1, 2. 0 comma 1. 1, 1, 2, 3, 4, and then 2, 7. 2, 1, 2, 3, 4, 5, 6, 7. This is a line that's been modified. Now we're going to talk about linear functions next unit. Next unit's all about lines. But what happened is it's become steeper, right? Y equals x was something like this. You can see that. And this has become steeper. That's what this coefficient of 3 will do. It makes it steeper. Makes it steeper. If this was a fraction, like 1/3, it would actually get less steep. Then this 1 shifts it up 1. So instead of going through 0, 0, it shifted up 1. This is the y-intercept. We're going to learn all about that next unit. Okay. Next up, let's look at this one. This one is y equals x squared plus 1. Y equals x squared plus 1. Well, we're going to go ahead and do the same thing. We're going to plug our numbers in, right? So y equals negative 2 squared plus 1, which equals 4 plus 1, or 5. So we got negative 2 comma 5. Y equals negative 1 squared plus 1, which equals 1 plus 1, which equals 2. So we get negative 1 comma 2. Y equals 0 squared plus 1, which equals 1. So we have 0 comma 1. Y equals 1 squared plus 1, which equals 2. 1 comma 2. And then y equals 2 squared plus 1, which equals 4 plus 1, which equals 5. So we have 2 comma 5. Okay, I'm going to go ahead and graph this. Don't worry, I'll move it so you can see it in a second. Okay, so I've got negative 2 comma 5, negative 1, 2, 1, 2, 3, 4, 5, negative 1, 2, negative 1, 1, 2, 0, 1, 1, 1, 2, and 2, 1, 2, 3, 4, 5. Now notice this is a parabola, just like our normal quadratic parent function, but it's shifted up 1. Just drawing a little arrow up 1. It's been shifted from here to here. Well, that's what this constant of 1 does. We've just taken the x squared parent function, y equals x squared. We've added 1, which means every value has 1 added to it, which means it shifts up 1 on the y-axis. Then finally, our last one we're going to do today, y equals absolute value of x plus 4. Okay, let's go ahead and plug these in. We've got y equals absolute value of negative 2 plus 4, which equals 2 plus 4, or 6. We got negative 2 comma 6. All right, that's a negative. Y equals negative 1, absolute value plus 4, which equals 1 plus 4, or 5. Negative 1 comma 5. Y equals absolute value of 0 plus 4, which equals 0 plus 4, or 4. Y equals absolute value of 1 plus 4, which equals 1 plus 4, or 5. So 1 comma 5. You can probably see where this is going. Y equals absolute value of 2 plus 4, which equals 2 plus 4, or 6. Okay? So again, I'm going to graph. Okay, I'm going to use red again. So our first value is negative 2 comma 6, so negative 1, 2. 1, 2, 3, 4, 5, 6 in the y direction. Negative 1, 5. Negative 1, 1, 2, 3, 4, 5. 0, 4. 1, 5, 2, 6. Guess what? This is still that v. This is still that absolute value function, v, but it's moved up 4 units. See how it's shifted up? Well, if we add 4 onto the parent function of absolute value of x, it just shifts everything up 4. Okay? So that's how to graph parent and regular functions. We'll be getting a lot of practice at in the next few days, and you'll be seeing some of these later on in the year.